Sorry, I pressed the video button and it stopped the video. I didn't know I could press that button with that hand, but yeah, so once the DFS, whatever, see it's like pulling up to 12 volts. See, now it's at 80, now it's at 60. It started at 40 or almost 20. It's already back up to 80, 100, because this battery is still like mostly good. I still have to, because it was brand new at the end of last year, but then like I say, it sat for like a couple months this summer, connected and drained. The snowmobile drained it, unfortunately. So the way these batteries work is, it's actually very simple. There are lead plates in this battery suspended in a pool of battery acid. And now when you connect, a load, like a starter to it, what happens is those lead plates have a reaction with the acid, and that reaction converts the lead on the lead plate into a sulfated state. And once the lead becomes sulfated, it falls off of the lead plate into the bottom of the battery. And once it becomes sulfated enough times and recharged enough times where the sulfation falls off the battery, eventually you have no lead left to sulfate. And at that point, your battery will be basically no good. It'll be dead. And you can tell how sulfated a battery is by how much resistance it has in it, because a fully bad battery will actually act as a resistor. Not only will it not give you power, it'll suck away any power that's in the circuit, like like it's its own resistor, like a light bulb or a starter or whatever. So if you can keep your batteries desulfated and 100% charged, they should theoretically really basically almost last forever, or at least for years and years and years. And now, let me just explain quick the difference between a standard lead acid battery, AGM gel, and wet. And motorcycle, actually, I mean, they're all related. They're all very similar because they're all 12 volts and they're all lead acid batteries. And the standard mode would work for AGM gel, wet, and motorcycle. But having these specialty modes does help it, at least if it's set up right, work a little bit better for those specific applications. So old-fashioned car batteries had lids on the top of them. You could pop the lid off and you could add water or acid. Because what happens over time is the more battery discharges and recharges, the liquid acid inside evaporates. Because when you're charging it up, it gets hot. And so eventually enough acid evaporates that the lead plates are no longer being covered in acid. And so what people would do back in the day is they pop the covers off, add a little bit of water, add a little bit of acid, get the pH right. Now your lead plates are covered again. Now your battery has full power again. But, like everything else these days, things are getting to be less and less able to be worked on by yourself, and everything's made to be disposable. So now batteries, they're like sealed. So you can't add water. I mean, some people will drill a hole in the top and add water because it does still help if you know what you're doing. But that's the difference here. So standard battery is basically a catch-all for any 12-volt lead acid, car, truck, snowmobile battery, motorcycle, whatever. But if you know you have an AGM gel battery, that's like a something glass mat gel. That's where instead of having lead plates literally in a bucket of acid, instead they have like gel pads that are like wrapped up and sealed so that it's not just a big pool of acid. Now it's sort of like, it's almost like how they make lithium batteries, how they just wrap them and wrap them and wrap them with the like electrolyte and the 2 layers. It's sort of like that, but for lead acid batteries. And then wet, that's the kind I was talking about where the lid comes off and you can add water or acid or whatever. At least I'm pretty sure that's what these are. That's my assumptions. I'm actually not 100% sure. And then motorcycle trickle, that's like, most people who have motorcycles, they don't ride them every day all the time. They tend to be like recreational, and so they sit for a long time. And when batteries sit for a long time, they tend to go dead. And so what this motorcycle trickle is for is to keep your battery 100% charged at all times. So that, you know, you can let it sit for 3 months or 6 months and you go to start it and it still starts fine. You didn't kill your battery. You don't have to buy another battery. So that's what all that is. I don't know if you've ever heard the terminology about pulling up. If you talk to electricians or circuit designers and stuff, they'll talk about something pulling a voltage up. I think that's why this arrow was pointed up to a 12 volt. I think it's pulling the voltage up. I could be wrong. Somebody correct me in the comments. But yeah, it's desulfating, DFS, I think, and pulling up the voltage. And once this 80% settles at 100%, and it detects no more sulfation in here, then it'll switch from DFS to FUL. Wow, could I have timed that any better? Battery temperature, 24 degrees, 14 volts. Charging at 0.9 amps. And there's Fahrenheit, that's kind of cool. It's a pretty nice charger for like $24. So it's done desulfating, which was this first stage here with the alternating current waves. Now I believe it's on stage 2, which is a constant voltage charge. And then after that, stage 3 is a constant current charge. And I forget what all these other stages are. It's like some fancy battery people figured all that out, so I don't have to. But, anyway. Yeah, I've got a lot of batteries to maintain these days. So, I was looking into a more affordable option than this. And I think I found it. So what I found out is basically, if you want to keep a battery fully charged all the time, it's going to be sitting a long time, and it's a 12-volt battery. You basically want anywhere between 13.3 to 13.8 volts. This is on 14, which is, you know, close enough. So 13.3 to 13.8 is what the internet says is safe, and it depends on the temperature and like the season. Because when it's cold, batteries drain more, I guess. So I think you want the 13.8 volts in the winter when it's cold and 13.3 volts in the summer when it's not cold. And that'll keep your battery 100% charged and not, then you don't have to go to the store and buy another $200 battery just because you didn't start your machine for like, you know, however long, and your battery's totally fried. So yeah, this one was it's too bad that, I mean, it's hard to say how many times a battery can be totally drained and charged back up before it's ruined, or, like I said, I don't have a way to test that yet. I think the way it's done is with resistance, because like I said, the more it gets ruined, the less it becomes a battery, the more it becomes a resistor. So I don't know. This battery's been fully discharged, luckily only 3 or 4 times. Even though one of those times was for like a few months, which is really bad because the longer it's discharged, the more damage happens in it. Really, you'd have to open it up and look at the lead plates and see how much of them came off, got eroded from sulfation, from being sulfated. That's what deep cycle batteries help with. They have thicker lead plates. So you don't get as much voltage because you don't get as many lead plates in there. You don't get as much surface area. But because they're thicker, you can sulfate them and abuse them way more before they turn into resistors and lose their charge. So we're already down from 0.9 amps to like 0.7, well, 0.8. Not a huge difference. But 1.1 amp is, 1 amp at 12 volts, that's 12 watts. So, I don't know what 8 out of 12 is. 2/3 of 12. Oh, it's whatever. Probably pulling about 7 or 8 watts right now. It's not too bad. The other cool thing is I hooked this up to my truck the other day, and I figured out that if I put it on motorcycle trickle, it's actually enough power for me to roll the windows down and turn up my radio and like listen to my radio at pretty decent volume down here, which is cool because I've got like nice speakers in there that I bought. And it's cool because like I was looking at the amps on here, and it was like 1.4 amps being drawn, and then I turned down the music, and then it was only like 0.8 amps being drawn. And then I turned off the truck and it was 0 amps being drawn 100% full. So that's cool. I like that I can sit here and run the radio as long as I want to without having to worry about ruining my battery. Because I actually just did replace this battery last winter too, which is too bad because it's weird. This truck always started no problem for like the 5 years that I've had it. And then one day in the middle of the winter, it just wouldn't start. And then I went to charge it and the charger said the battery's failed. You need a new one. I think what might have happened was I think I may have started it and moved it like 10 feet and then turned it off. And that didn't give it enough time to recharge after that start because starting takes a lot of power out of the battery. And then the next time I went to start it, it had been drained so much from the last start and sat for so long that was like the last little bit of life that battery had in it. I don't know. It hurts my head to think about these batteries too much because like it gets really complicated the more you look into it. But anyway, like I was saying, I was looking online at like voltage regulators and transformers because you can buy like little mass-produced chips that are like this big that'll like convert AC to DC or DC to DC, and they've got like a little knob you can turn to set the voltage output exactly what you want it to be. Now I've used them before for like projects. They're like 30 cents. Now they're up to like $1.50 because it's like years later. But now that I know that basically 13.3 to 13.8 or so is like the ideal constant voltage to keep a battery in good shape, I want to order just like a batch of those cheap little voltage transformers, DC to DC buck converter probably, or whatever. Because I've got a bunch of old DC adapters that I just collect from the years that I don't use because I know they'll be useful someday for something. So I've got like 2 huge paper bags, not huge paper bags, 2 normal sized paper bags of DC adapters that are just not being used. So I can hook those up. I can get those cheap little voltage, DC to DC voltage transformers, which are amazing because like years ago when I was a kid, those didn't exist. That's why AC was so nice because you could transform it. But they got these buck converters now. And it's like it basically turns on and off like thousands of times a second or whatever to regulate the DC voltage, like pulse width modulation or whatever. They call them a buck converter, B-U-C-K. So I can get whatever DC adapter I have, 9 volt, 10 volt, 12 volt, 14 volt, and then I can put it to the input of the little chip, and I can put the output to my battery, and I can set the output voltage at exactly 13.3 volts. And then I don't have to buy a bunch of $24 battery maintainers, and then the cheap battery maintainers, they are just DC adapters. The problem with them on Amazon is their 12 volt output, which will keep a battery like 90% charged, but you know, like I said, what you really want is 13.3 to 13.8, not 12. So, you know, I've got the Passat down there. Oops, wrong direction to zoom. I've got the truck, got the snowmobile, got the plow truck, I've got the tractor, and then I could probably think of more if I spent more time, but that's at least like 5 batteries that need to be, or should be, ideally trickle charged, at least for the winter time, if not all the time, so I don't have to go buy new batteries again because they are expensive. So anyway,